Good afternoon and most welcome to 1425 of the series. We will continue and strive on into the venture and adventure of fractal dimensionality. We are now currently at page 13. Do remember in the section on the Terry MARKS-TARLOW homepage, the pages are numbered differently in some cases. Do look out. But this is the chapter that begins with fractal dimensionality. The endless space between dimensions. To understand how fractals model identity in nature and bridge various realms of space, time, and imagination, it is important to examine how fractals illuminate aspects of subjective experience. Where does consciousness begin? Where does it end? What are its bounds? Especially given that the subjective feel of conscious awareness seems to extend across boundaries. From inside our heads to outside of our bodies. How does the invisible substance of consciousness relate to the materiality of our brains and bodies? What is the difference between an objectively measurable event and a subjectively held experience? All remain disputable issues, often relegated to the realm of philosophy. A complete answer to these questions is beyond the scope of this chapter. However, before highlighting a couple of issues relevant to this discussion, I began with a disclaimer. In sections that follow, including the list of epistemological principles at the end of this chapter, I do not claim to have solved what is labeled the hard problem of consciousness, as formulated by David Chalmers. I will not go into that because we read that 2 times before. It's in page 201 in his 1995 book. Chalmers formulated the hard problem as difficulty explaining the content or qualia of conscious experience. He outlined and then dismissed the success of various case studies proclaiming to explain consciousness, including Crick and Cox. Suggestion that gamma oscillations in the cerebral cortex provide the neurobiological correlates of consciousness, or Penrose's 1994 suggestion from within a nonlinear dynamics perspective that non-algorithmic processing explains mathematical reasoning. I want to clearly state that I'm not presenting a theory of conscious awareness or an explanation of how we come to experience its various qualia. My commentary, qualia is almost like properties, things that are beyond the material, so to speak. Instead, I offer a fractal geometry as means of modeling some features that pertain to the structure of subjective experience. Including the possibility of open boundaries between conscious awareness and physical material levels of brain, body, and surrounding environment. Keeping these limitations in mind, I turn next to an important distinction between objectively measurable events and subjective experience. Objectively measurable events are discrete and observable. To measure something, clear boundaries must be present, plus a clear value within those finite bounds. Subjective experience, by contrast, carries the feeling of being immeasurably and infinitely deep, with borders that feel fuzzy and ambiguous. Perhaps there is a unified field of consciousness, a truly transpersonal extension of invisible, subjective dimensions into objective realms. Shamans who claim to transport themselves through their astral bodies could possibly be such a case. The true potential of consciousness remains unknown. But again, most relevant to this discussion is the subjective feeling of fuzzy boundaries and infinite extensions. Both during contemplation of inner worlds as well as during perception of external worlds. This very sense of boundaryless interconnection complete interpretation of inside and outside realms correspond to mystical experiences and peak states like non-dual awareness, whether facilitated by psychedelic substances or occurring naturalistically. It's a very important point here, as Ian McGilchrist in his books, especially the latest one, often points out that the spiritual life is gone today. We know that as a fact. And you see here how fractality can bring spirituality back as something inner that doesn't have to be reduced to something outer. How does a mystical sense of infinite extension relate to fractals? When I first came across this new branch of geometry in the early 1980s, I immediately had the intuition of something profound about fractals. At the time, I was attending a weekly drawing group that included the physicist Richard Feynman, and we had become quite good friends. Because Feynman was deemed the smartest man in the world, I rushed to him with the question, "Don't you think fractals are profound?" Someone standing nearby asked what a fractal is. Dick took several minutes to give a state-of-the-art explanation of fractal geometry. Its hallmark features of self-similarity, scale invariance, and more. I waited patiently, and once Richard had finished, I asked him again, "Don't you think fractals are profound?" His response, "I don't understand them," absolutely shocked me. How could this be when Feynman had just explained fractals so eloquently? Crestfallen, I was left utterly alone to find my way forward. It has taken me decades to flesh out my understanding of fractals, including 15 years to write Psyche's Wheel, MARKS-TARLOW 2008. Which applies to chaos theory, complexity theory, and fractal geometry to clinical practice. To this day, I still do not understand fractals fully, nor do I believe I ever will. But one thing I'm quite certain of, my initial feeling of profundity relates to the role infinity plays within fractal construction. And I think that is interesting. You never stop learning of fractals. It's an unending deepening. Whereas in Newtonian understanding, there is an end. Knowledge is infinity. Any knowledge that has a definite end is no knowledge at all. It's not an understanding, and neither is it knowledge. Let me explain. Ordinary Euclidean dimensions are finite. That is, they consist of whole numbers such as integers. Points are zero-dimensional, lines are one-dimensional, planes are two-dimensional, solids are three-dimensional. Einstein offered time as the fourth dimension, while others view imagination as the fourth dimension. Human-made objects, such as the top of a table, have clear boundaries within the confines of finite Euclidean dimensions. The measurement of a table's circumference is resolvable. We always arrive at the same approximate answer, no matter how large or small our measuring device. Whether our ruler is 6 inches long or 6 feet long, the measurement of a table's circumference remains essentially the same. None of these conditions apply to fractals, which are multi-scaled objects that are not finite. But infinitely deep, at least in theory. Because of the properties of being multi-scaled and infinitely deep, fractals do not have clear boundaries. Their measurement is not fixed but fuzzy and dynamical instead. To illustrate this, consider the Mandelbrot set, the granddaddy of all fractals and the most complex mathematical object known to humankind. To construct the Mandelbrot set, the same formula is iterated for every point of the complex number plane. Iteration means that the end product of an equation is fed back into the beginning over and over. That is recursively, until the equation resolves itself, or does not. In figure 1.8, the solid black areas represent the finite zone, where the formula resolves to a fixed number. The white areas represent the infinite zone, where the formula goes on and on, extending towards infinity. The complex border between these two zones represents the dance of the Mandelbrot's intricate multi-scale pattern. And this is important, I say before already. This edge of complexity is infinitely deep. This edge of complexity is infinitely deep. To expound that, it can contain an infinity of knowledge. Unlike the line, unlike the square or the point of the modern educational system. This means that when a computer is used as a microscope to zoom in on a particular area, a new pattern emerges dynamically and unpredictably. Figure 1-8 reveals 4 scales of zoom on the Mandelbrot set's complex edges. Notice the self-similarity that reappears in the 4th square. Such that the very similar shape of the whole reappears, making it quite difficult to tell what is inside and what is outside its borders. From this example, we can see that fractal geometry is a very visual form of mathematics that is intimately dependent upon the prodigious calculating power of the computer. This fact helps explain why fractal geometry was not discovered until the 1970s. And that is also incredibly pertinent here. You need to understand everything that is based on the understanding before the 1970s is wrong. It's simply wrong. It takes Euclidean space, it takes the point, it takes the line and the square, and that affects a specifically thinking as expounded by Ian McGilchrist and of course John Cutting, making it unwholesome and non-working. Fractality needs to be included in any sort of education for there to be any knowledge value in it. This is the working of the world that's been ignored. fractal zooms abound on YouTube, and it is highly illustrative to watch a few of these short videos to get a feel for the endless beauty and depth of fractal geometry. To more fully understand the infinite aspect of fractal geometry, I now present the concept of fractal dimensionality. Contrary to ordinary assumptions, fractals grow in the endless space between finite Euclidean dimensions. Mathematically, the discovery of fractals required expansion of the very notion of dimensionality, such that each mathematical fractal not only has a discrete Euclidean dimension, but also has a fractal dimension consisting of fractal number that carries the potential of being infinitely variable. Subfigures 19a and 19b illustrates how ordinary scribbles as well as more formal Sierpinski carpets occupy the space between a one-dimensional straight line and a 2D plane. Subfigures 19c and 19d illustrate how the Sierpinski triangle and a fractal mountain generated from triangles occupy the space between a 2D plane and a 3D solid. In general, no matter what the Euclidean dimension, the higher the fractional dimension, the more complex the fractal object. Figure 110 shows the same fractal mountainscape rendered in lower versus higher fractal dimension. Fractal dimensionality. We can now begin to see how fractals help to quantify qualitative features of nature, like the ruggedness of a mountainscape, the jaggedness of a coastline, or the fluffiness of a cloud. In an interesting recent application, the fractal dimension of Rorschach test figures were quantified. Despite initial speculations that Rorschach dimensional complexity would mimic that of nature, e.g. cloud patterns that resemble Mickey Mouse or a submarine. The Rorschach figures are relatively lower dimensional than Mother Nature, revealing a slightly different fractal sweet spot that is best suited to the projection of visual imagery from imagination. Fractal paradoxes. Mandelbrot posed a now famous question: how long is the coastline of England? At first blush, the answer might seem straightforward, yet because of the multi-scale quality of a coastline's fractal shape, paradox lurks within, connected to the construct of fractal dimensionality. Mandelbrot claimed that the length of the coastline of England is infinitely long, and what is more, every other natural coastline is also infinitely long, along with any arbitrarily short subsection of coastline. Could you hear that? Any arbitrary short section of the coastline is also infinitely long. Defies the pre-1970s thinking, which is deeply ingrained in us. Subsection is also infinitely long. Mandelbrot's assertion emerges from fractals as multi-scaled objects. The property of infinite depth renders a single definitive measurement impossible. Instead, the number one arrives at depends intimately on the size of our measuring device. Counterintuitively, the smaller the ruler, the larger the number. The resulting quality of observer-dependent measurement, and in the measuring, as was asked earlier, the subject is evident, because that is the subject. It is not part of the objective side as we normally see it. It is the subject. So you see, fractality is a segue to understanding quantum mechanics. You ease yourself without the math. All you do is understand these academic things that pertains to abstract thinking as foundational. We will now look into the body of fractals, the spirals. And this is common from Raymond Dart, the South African anthropologist that discovered spirals in our bodily system, and that they make up the integrity of a human being, and they make no distinction whatsoever of mental or material, flesh or mind. The spirals go through thinking and through the body. I'll put in a short box there. Raymond Dart discovered spirality in the bodily mind system, and that's a precursor to the discovery of fractals, and he used that to understand how the body really moves and what is directionality, what is communication. Usually it's thought that communication is a passive activity that is just inherited. It shows rather in modern research many people cannot communicate whatsoever. That takes the golden ratio, the spirality. It takes that there is a hole in the wholeness. And those holes are, of course, the movement that is the stillness of the body. And this seems paradoxical for the pre-1970s thinking, but it is absolutely necessary to have a functioning body. I've been walking around here earlier on and see how students here are sitting in positions that will damage their bodies permanently eventually. And these are medical students. No body on earth is made for this chair. It is bent for the body to be collapsed, non-working, in the state of repetitive thinking, which is so characteristic of academia today. The same things and no new learning. It is actually zero. Creativity shockingly goes down after a 4-year study period, and it goes down to almost the low level of 32%. So it's damaging. But today we will look at the body. If Kali, you could please go to the chair and stand, yes. And we just sit down the normal way, the new academia.
No, normal way. I don't want to damage myself.
We need to show.
Okay.
We need to show how it looks like. Yes. This is that hardened, uneasy, sharp way of going down. And you see his hands there are clenched. Well, they were clenched before actually. This way of holding the hands is also very, you can leave them that way so we can just see it. The clenching is because there is an abnormality in the balance of the system, and that can be redeemed. And what you need to do is spiral.
They're clinched because I'm a Spartan.
So do spiraling.
Okay.
But don't do anything with the body. It needs to be in the body-mind system. So the spirals are entering into the thinking. And I think, yes, that's much better already. And although it's hard on this chair, I ask you to try to find the pivot. Yes. You can actually wiggle both sideways. Yes. Slowly, and slow down and go like a spiral, you see here, and make it smaller and smaller until you, yes. This is how you do it, the Dart procedure.
Okay, I begin with a big spiral movement.
Yes, but think at the same time. You're not thinking now. can see that. Don't be academic or neo-academic. Be intellectual, as Alexander Doffer said. Let intellectuality enter your life. It's a bit more conscious, but then you stop when you find the spot, and you will find it. And here I suggest that you try this frequently. It's the iteration that does it. It will not be understood the first time. So it is by constantly iterating it. And I would say, because each iteration is different, understanding will come. We had this example 1 year ago, and then we were speaking about the Spanish word caña. And very important to get the iteration of caña is to pronounce it differently every time. To strive for identity or self-identity will make understanding impossible. So it is a neat connection between how we understand things in the old way to be identical, and there is a sort of a correct understanding you can reach immediately. But in this case, as Kalle is demonstrating, you ease into it, and you're never fully there, because the fractal depth is infinitely. What does that mean? It means that even if he finds the most perfect balance he ever found, that can be improved. So there is no, like there is in schooling system today, 2 squares, one for correct and one for wrong. No, it's a deepening of the posture. That actually looks quite good. And once you get into that balance, you should feel relaxing in the thinking system as well. And I suggest in this lecture I will not illustrate the dart procedure, which is also constructive rest, but thinking of the spiral as well, you do that. And I suggest Kalle do that now. I think he already is. It's very good, actually. Will help constructive rest as well. And it will help your thinking. Remember what Alexander says. Alexander technique is a training in thinking. It's a training in understanding. Well, it's a training in knowledge, to become more knowledgeable. And it's not about what in classical physics is called the physical body, to do something with the body. But this is a way of easing into it. It looks very good, actually. You look more relaxed now. And I end with a vision of the spirality. I see if I can't have an entire lecture with Raymond Dart and the connection between thinking and movement, which is incredibly fractal in itself. Thank you very much, Kalle Lundahl. It was a pleasure. And thank you for listening in. Bye-bye for now.